ফ্লো করতে পারে কন্ডাক্টিভিটি মানে।
Okay.
অ্যাপ্লাইড
Anyone else?
কারেন্টের প্রতি কিভাবে ম্যাটেরিয়াল বিহেভিয়ার করতেছে?
Right. That means we get conductivity because of the movement of the charge, right? That means
Yes,
charge
sir.
has to be moved. No matter whether charge is there or not, charge has to move. If charge does not move, then we will not get conductivity. And conductivity we get when charge moves through the conduction band, right? We'll study conduction band later, but later we'll see when electron moves through the conduction band from atom to atom, then we can get the conductivity. So if you have charge, then what you need to do? Okay, in case of metal, we know that the electrons of the outer shell are loosely bonded and they move from atom to atom, right? Generally in a cloud. So even if there are free electron in outer layer or in terms of semiconductor conduction band, for conductivity, you must apply a voltage. Why? Because when you will apply a voltage, then the electrons will start to move. Actually, we'll see later that electron can drift because of two reasons. Can you tell without voltage, does the electron move?
Or in an applied electric field?
Without applied electric field, is it possible?
The magnetic field.
by through
No, if you don't
heat,
apply any, yeah, right, excellent, heat. So where the heat comes from?
temperature
কারেন্ট ফ্লো
gradient.
হলে রেজিস্ট্যান্সের
Right.
কারণে হিট তৈরি
Right.
হয়।
Yeah, due to resistance it is generated. Right, but even at normal room temperature, because of the heat, electrons can move, right? But in this case, electron moves randomly in all the directions, so you don't get conductivity because of the thermal energy initially. But whatever, what you can do, if you can apply a voltage, then electron will move from one side to another depending on your applied voltage direction, and that voltage will provide you the conductivity. Clear? So when you apply a voltage, we have positive potential on one end, negative potential on another end, then obviously electron will move from one end to another end, and that is the conductivity. So basically conductivity is the material's response to the applied voltage. When we apply the voltage, how the material is responding, right? Now, firstly, we have material all around us with different type of conductivity. Okay, completely different type of conductivity. For example, if you have if you think about the wiring, electronic wiring in our houses, right? So what are the materials that make the wire? Wire is made of what type of material?
Insulator
Copper.
type of material.
Insulator is outside only, but inside
Yes,
core is copper, right?
Yes, sir.
Yes, sir.
Yes, sir.
Inside core is copper, right? So that means for copper, we need high conductivity or low conductivity?
High conductivity.
Very
High
high.
conductivity.
Right, very
High
high conductivity. But at the other end, the cover should be completely insulating, right?
Yes, sir.
Why?
Yes.
Why? What will happen if the cover is not insulating?
So we can get
কারেন্ট
shock.
ফ্লো হইতে পারতো অন্য সাইডে, ইলেকট্রিক শক।
Yeah, electric shock is
There
one
will
of
be
the
leakage
reasons.
of current. sir.
Have you seen the high voltage wire on the road? Do you
Yes,
see any
sir.
insulating cover there?
No, sir.
নো স্যার।
Why? Why
No,
not?
sir. এটা গলে যায় স্যার, গলে যায় এই কারণে।
Right, because there is a huge current. But whatever. So is it usually what we try? We try to have some sort of polymer coating, insulating coating on the wire, so that you don't have direct contact with current, right? So that means the insulating material have a very high resistance, which is covering the core. On the other hand, the core has very high conductivity. Again, you see the filament. If you think about the filament of the bulb, right? They have low resistance or high resistance?
Very high resistance.
Very high resistance.
high resistance.
Very high.
হাই রেজিস্ট্যান্স, হিট জেনারেট করে
So
এরা।
yes, so high resistance results in generation of heat. That means if we apply the current and we increase the current, then due to resistance, we get heat, and from heat we get light. So normally you say that if you apply a voltage across two terminals, a current I pass through, the resistance is the ratio of voltage to current, and that is constant. This is the Ohm's law, right? So this Ohm's law is known as electrician's Ohm's law because you can explain the resistance only in terms of voltage and current. Voltage and current, none of these are related to metal. Can you, just looking at here, can you explain if the resistance of copper is higher or if the resistance of iron or chromium is higher? Is it possible?
No,
No,
sir.
sir.
No.
No, sir.
That means you cannot explain why copper core has a high conductivity, why the polymer coating has a low conductivity. We cannot say why filament has a very high resistance, we get light, but we don't get light from the electric wire, right? Our electric wire, we don't get any light, but we get light only from filament. So that means if we want to know why they are behaving differentially, we must relate this resistance with some variable or constant. Those are related to the material properties directly. So that's why we want to modify this Ohm's law so that we can explain resistance in a different way. Okay, now according to Ohm's law, V by I should be constant, right? If your voltage is high, your I will be high. If your voltage is low, your I will be low. But what happens in real? This is called ohmic device. Ohmic device means when your V by I is constant. Look at this diagram. Here, I is in y-axis, V is in x-axis. So here, with increasing voltage, V by I is increasing or decreasing?
It's decreasing.
V by
Increase. Not linearly increasing.
It's increasing because it's I by V. I by V is decreasing. That means V by I is increasing. Its y-axis is I. So slope is decreasing. I by V is decreasing means V by I is increasing. I have another card actually. This one. This is for ohmic law. This one you see V by I is increasing, right? At high voltage, V by I is increasing. So when V by I is increasing, what does it mean? Resistance is constant or increasing or decreasing?
Increasing, sir.
Resistance
Increasing.
increasing.
So increase of a bulb, when you increase the current, actually, due to resistance, you are getting heat and finally you are getting light. But the interesting thing is, because of heat, because resistance of our heat provides light, but because of the heat, actually resistance goes high. That means you also know that when temperature goes high, then the mobility decrease, right? Though we did not, we are not explaining mobility still, but we know that in case of metal, at high temperature, conductivity goes down, right? Everyone knows that high temperature, conductivity of metal goes down. Why? Because
Collision
electrons
there is
move, right? Electron moves very fast, there is collision, and because of collision, their mobility goes down. So if temperature goes high, then it will affect the mobility. As a result, resistance will not be constant anymore. So at high temperature, resistance will be high or low or constant?
High.
High.
Low.
High.
Low. At high
Low.
temperature, at high temperature, sorry. At high temperature, resistance will go high. So Ohm's law will follow or not anymore? Ohm's law will not be followed anymore, right? Because Ohm's law says its resistance should be constant. But you see here that with increasing current, if temperature goes high, then resistance will be high, and then our Ohm's law will not be valid anymore. So what we can say, that Ohm's law will be valid only when, if
limited
temperature does not
range
change. Okay, so you must remember, everyone, that Ohm's law is only valid if temperature is not changed, or if temperature change within a region, within a range. After the range, because if temperature goes very high, then mobility will be affected. Ohm's law will not be valid anymore. But now another thing, we have many material systems where we can have we can see that even without changing the temperature, it is possible that Ohm's law is violated. Okay. Before that, one thing I want to say again: in case of bulb, what we see at very high temperature, resistance is high or low? High, right?
Yes, sir.
At very high current or voltage. But there are some materials what we use at the roof of our building for lightning protection. Okay, those type of materials are designed in such a way. It is called varistors, right? It is called varistors. It has a greatly reduced resistance at high voltage, just opposite to those we just discussed about bulb. In case of bulb at high voltage, resistance goes high. But in case of varistor at very high voltage, resistance is very low. What happens then? When during the lightning, the current can directly pass through the varistors to the ground. So our building will not be electrified, right? So that means we can design material in such a way so that Ohm's law is violated. That means violation of Ohm's law is not only a natural incident. We design material so that Ohm's law can be violated. If you think about the calculation system in semiconductor, that means calculator system in computer or in calculator, when you do the calculation, actually we use this sort of non-ohmic law so that current pass in directional way. Another easier example is the rectifier, right? What is the rectifier? Rectifier is, alternating current has always changed its phase, direction, right? Magnitude or phase. So once it has the direction, after the next cycle, it reverses direction. And you know what is the rectifier, right? Rectifier makes AC current into DC current. So how alternating current is converted into DC? Because this type of device allow current in one direction and does not allow current in another direction. So if you have alternating current, it will be converted into a DC current, right? So that means that in many cases, we can design material which will not follow the Ohm's law. These are called diode. Diode act as rectifier as well. Here you see that at high voltage, you may increase the resistance, or at high voltage, you may decrease the resistance. Different type of material we can design, right? So from here, we can make the summary that Ohm's law says that the ratio of voltage and current is constant, but actually it is not always. In natural way, if you think, it is only valid unless your temperature will change so much, because if temperature goes very high, then due to decreased mobility, your resistance will be high. And also you can design material so that this violation is possible. Now we need to know how we can design these things, why Ohm's law is violated, why materials are behaving differentially. Actually, you see, we cannot explain any of these things from this formula, right? We cannot explain anything. So that's why we need to change the formula. Otherwise, we cannot explain these things. So far, do you have any question? Confusion?
No, sir.
Okay. So now, if we apply electric field anywhere, electric field means a potential difference. If we apply a potential difference anywhere, like between 2 points A and B, the distance between 2 points is L, right?
L.
So we apply a voltage. Actually, electric field means electric field is applied with applied voltage. So when we apply voltage between 2 points, then volt per meter is called the electric field. Electric field means volt per meter. That means across 100 millimeter, if you apply 10 volt, so you have to divide 10 volt by 0.1 meter, right? So that will be 100 volt per meter. That is called the electric field. That means over the same distance, if you can think about this length as the length of the wire. So if you apply more and more voltage across the two ends of the wire, electric field will be more high, so your electron will feel more driving force to flow, right? So do you understand this formula? Electric field is the ratio of voltage and length, right? So
Yes,
from
sir.
here we
Sir.
can say voltage equal EL. Okay. The second thing is the current density. Okay. Current density actually is flux. Okay. current density is a flux. In kinetics, we say always there is a flux and there is a force. That means if there is a force, it will result in a flux. For example, water is flowing from top of the hill. So water has high potential energy there on the top of the hill. That is the force. And the flux is water will flow from top to bottom. So what is the flux? Flux means flow of anything per unit area, actually, right? So if you see the current is flowing perpendicularly through a cross section of A, then per unit area, the rate of current flow is called the density, right? That means ampere per meter square. Per unit area, how much current is flowing, that is the current density. So where you can say I equal JA. Okay, I equal JA. We are following the book from of D. Livingstone. Okay, so here when you will go through the book, actually you see that the book shows only the initial formula and the final formula. Okay, so but you will need this derivation, so you will get the derivation in my slides. It's very simple, you can easily do that, but in the book it is not mentioned, the details. So we found two equations, V equal EL and I equal JA. Now we know V equal to IR. This is Ohm's law. V by I equal R or V equal to IR. Now what is the value of V? Value of V equal EL.
EL.
So put here EL. Then IR. I will be here.
J.
I equal JA and R equal, we know, rho L by A, right? So rho is a resistivity of a material, but you still see rho means rho L by A. Rho is resistivity of material. Now we know it's a material property, but still you need dimension. Still from here, you cannot explain, right, why bulb is behaving like that, why at high temperature resistance is increasing, or copper has a high conductivity, lead has a low conductivity, anything you cannot explain from here. That's why you are still changing the formula. So EL equal JA multiplied by rho L by A. So A is reduced here. So EL equal rho EL equal rho JL, right? We have rho here, J here, L here. A is reduced, rho JL. Now from both sides you have L, so we have E equal rho J. That means rho equal E by J. This is the constant. Now you see, actually I said you that every formula comes from kinetics, right? I mentioned yesterday. This is a flux. This is a flux, and this is a force. When there is a force, this force will always give you a flux. For example, you are standing at some place, okay? I am trying to push you. That push will work as a force, right? So what will be the flux then?
আমার পড়ে যাওয়াটা বা আমি এদিকে
Move
Right.
move.
Right. So if I push someone, that will work as E, and that person will move, that will work as J. Now tell me, if you try to push 10 people, do you think everyone will move in the same way? No, right?
No, sir.
It will depends his resistance, how he can resist you. That resistance constant is the rho here. That means in kinetics, it says that if you apply any sort of voltage, for example, you are studying, what's the response you are getting in your result? You are studying, you are doing some good results or not good results, whatever it is. When there is a reason, or cause, when there is a force, you will always get the flux. It is not about electrical property. It can be about diffusivity. It can be gradient. It can be diffusion. It can be diffusion constant. Thermal property, electrical or optical, for any property, when there is a force, there will be a flux. And with a certain force, different material will give you different flux. So how the flux will be? Flux will be high or flux will be low. It is decided by a constant. And that's why we always, when there is a proportional sign, we just put an equation and then put a constant, right? When there is any proportional sign in mathematics, we always put equal and a constant, because the constant says that how this density term responds to the applied field, whatever. So we can say that rho is the ratio of E by J. This is material scientist version, but still you see it is not still in proper form, but we can understand now that okay, the resistivity is now related to the applied field and flux. Now we can at least understand that that this is the ratio of force and flux. What it indicates, if I push someone, how fast he will move, it depends on his own capability, right? Now we understand that, okay, so rho is somehow related to material property. Material is responding fast or material is responding low. So this equation at least indicating this. But if you look at V equal IR, it looks like resistance depends on how much voltage you are applying and how much current is flowing. But now we can directly understand that since there is a J means electron flow per unit area, but actually indirectly you can say that from current we still get the idea. You can say that, but here later we will convert this J, we will explain this J in terms of electron concentration. Because what is the flux? Flux is electrons flow. So you have to know how many electrons are there and at what velocity electrons are moving. So when we will relate it, this equation in terms of electron concentration and mobility, then actually you can directly say that in copper, why electrons moving fast or slow? If in copper electron concentration is high or low, then you can easily explain the properties that why at high temperature electrons collision increases, that's why mobility decreases. Everything you can explain when this formula will be further modified and we'll get some parameter here like electron concentration and electron mobility. So we are not done yet, but so far we can say rho equal E by J, or you can say we know that 1 by rho equal sigma conductivity. So you can just say J equals sigma E. So this will be the modified law, Ohm's law. We will modify it later in our next class again. But so far, our formula will be J equal sigma E. And here is the example, you see, just a simple math. A metal has a conductivity at room temperature, 5.92 into 10 to the power Siemens per meter. What is the resistance of a wire? 1.8 millimeter in diameter and 50 centimeter long. If the wire is carrying a current of 1.3 ampere, what is the voltage applied to the wire and the electric wire and the electric field within the wire? So firstly, you have given the value of sigma. So we can get the resistance by 1 by sigma, right? It's simple. Then length is given. Ampere, current, area you can
Area.
calculate because the diameter is given. Then you can calculate the resistance, rho equal rho L by A. Then by directly applying the Ohm's law, V equal IR, you can get the voltage. And others are very straight formula, like you have to find out the electric field, E equal V by L. You can do the cross check by J equal I by A because you have the current and you can do the calculation. So another important thing we need to know here, this is another important thing. Okay, before going there, just see example that how conductivity changes. You see it's the log scale, right? Log scale means 10 to the power 7 and 10 to the power 6. It means almost 1000 time change, right? If you see that in case of copper, your conductivity is 10 to the power 8. In case of diamond, your conductivity is 10 to the power minus 16, right? Or if you think about resistance, the resistance is 10 to the power 16 here and 10 to the power minus 8 here. You have silicon in between. So these are insulator. These are very good conductor, right? And these are semiconductor. So you see that conductivity changes by order of magnitude 10 to 24 minus 16 plus 8. So there is a huge changes conductivity of material, and all ceramic type of material even behave sometimes like insulator, sometimes like semiconductor, sometimes like insulator or superconductor. So that means this wide range of change in conductivity is possible within the material, and how that is we'll explain by explaining the electronic structure. Now, do you have any idea about tensor?
No, স্যার হালকা পাতলা স্যার অত ভালোভাবে না,
So-
দুইটা ডিরেকশন আছে সেটা।
Right. So usually we say vector. Okay. So in case of vector, actually, we think that vector has 3 components. Like I think in different cases, for example, F equal, no, not F equal F. I think you have solved the equation like V equal U plus AT, V equal UT plus AT half AT square, right? This type of
Yes, sir.
equation,
Yes,
when
sir.
you proved, sometimes you derive this equation considering that velocity, acceleration, these are scalar. Sometimes you consider that these are vector, and you took 3 components and you derive the equation in one direction or directly as vector. So when you consider vector, usually you think that it has 3 components along x, y, and z direction, right? But actually, think about a block of a cube. Okay, at a cube, you have at the origin you have a stress applied. Now you have 3 components: one component along x-axis, one component along y-axis, and one component along z-axis. Now, for a cube, for a cubic structure, I don't have an image here actually. If you have a cube here, cube in your hand, if you apply 3 stress along x, y, and z direction in equal amount, do you think that that cube will move at all?
No, sir.
No. If you apply 3 axial stress on x, y, and z axis at equal magnitude, the cube will not move anymore. What will happen if you apply, for example, on a cube on 2 dimension along x and y, and if you the cube cannot move because the cube is hinged at the origin. So if you increase the one of the axes, then actually cube will try to rotate. If I can explain, actually, this will create some shear stress. Do you understand what is shear stress? Shear stress is the stress that acts in
Tangential
parallel
force.
to the surface, right? Tangential force, right?
Surface বরাবর যেটা
Surface. So when it works, when your sigma 1 and sigma 2 are not same, usually then you have a coupling force, you have a shear force on the surface. I can give you, try to explain mathematically. For example,
স্যার এটা কি
okay,
এরকম যে মানে একটা কিউবের কোন একটা ডিরেকশনে যদি ফ্লুইড ফ্লো করে তাহলে 9টা ট্যানজেনশিয়াল আমরা পাই, অংশ পাই,
right, 9,
এরকম কিছু?
9, right. 3 will be axial and other 6 will be the tangential force. Okay, for example, here you see the conductivity. This is actually everything from kinetics. For example, you have a flux J1 in one axis or x-axis, J2 along y-axis, J3 along 3-axis or j-axis. Now you say how we write the equation. J1 equal sigma 1 E1, sigma 1 into sigma 1 3 E3. In case of sigma J2, sigma 2 1 E1, sigma 2 2 E2, sigma 2 3 E3. In same way, we can write the last equation. So now you see when you will not, okay, we write stress equal modulus into strain, right? Stress equal modulus into strain. Then you have to write here sigma 1. Okay, stress, strain. So it will be strain. If it is stress 1, it will be strain 1 here. Okay, and modulus will have the component. In same way here, the relation, same thing. Stress, strain, modulus. So if this is 1 1, 1 1 means along x-axis, the relation between J and E. Sigma 2 2, it means the relation between
y-axis
right means J2 and E2, and here sigma 3 3 means along g-axis, the relation between J3 and E3. If you think that they don't have any shear component, then sigma 1 2 will be 0, sigma 1 3 will be 0, sigma 2 1 and sigma 2 3 will be 0, sigma 3 1 and sigma 3 2 will be 0. Then your all these cross functional term will be 0. So only sigma 1 1, sigma 2 2 and sigma 3 3 exist. Okay, then actually eventually you can go to sigma equal to JE. Sorry, J equal sigma E. Directly you can write that because that's along extent. So it just to give you an idea.
একটু আরেকবার বোঝানো যাবে এই পার্টটা?
That means here you have some longitudinal component which is sigma 1 1. What sigma 1 1 means? If you forget about everything, just see this portion. Just see this question. That means J equals sigma E. J equal sigma E, right? So along x-axis, J1 is proportional to E1 and you have sigma 1. If you just think this component equal J2, just J2 equal this one, that means J2 is proportional to E2, you have sigma 2. If you think about J3 and this one, J3 is proportional to E3, sigma E3 is component. But what we usually directly write, we just write that J equal sigma E. So J1, 1, E11, J22, E22, J33, E33. But as a vector, you can write J vector equals sigma E vector. So it means that
Yes, sir. Thank you.
it means that this equation, but when there is no shear component, then this one will be 0, this one will be 0, this one will be 0, 2, 3 will be 0, 3, 1 will be 0, 3, 2 will be 0. Then the equation will be simplified. I think in 1, 1 or 1, 2 level, you have done some of the courses like that, like identical diagonal function when the coefficients of other shear becomes 0, how you can do the calculation. We'll see some of the maths when we'll calculate eigenfunction or something later. But here just we want to give you idea that all these vectors are actually tensor. But for simplification, we will always just consider the simple vector form. Okay, because if you think about material, actually materials are not isotropic. Materials are isotropic or anisotropic usually for any properties.
Cubic
Mostly
isotropic
anisotropic.
Usually anisotropic, because if you think for any material, actually it is anisotropic. But if you just think that it is polycrystal and all the crystals are completely randomly oriented, then you can think that, okay, probably it is isotropic. But otherwise, all the time materials are anisotropic. So that's why it's very important that tensor form we consider. Okay, and one of the important thing is, again, we are saying, we see that without modifying the Ohm's law in such a way, until we see that electron concentration or electron mobility in the formula, we cannot explain many properties of the material. What type of property we cannot explain so far? Like why Ohm's law is not valid when temperature goes high. Because when temperature goes high, mobility is affected, but mobility is not present in the Ohm's law. We cannot explain why copper has a high conductivity. We cannot explain why the coating has high insulation. Then we cannot explain like why at very high voltage resistance drops for lightning protection in varistor. We cannot explain how the rectifier works. We cannot explain how alloying can affect your properties. Okay, adding any alloying elements will increase or decrease the conductivity.
The increase.
Increase.
Anyone can think about it?
Decrease.
So decrease ও করতে হবে,
both
increase ও
can
করতে হবে।
possible.
Both
দুইটাই
is
তো
possible.
দুইটাই তো
Can you give example? Both is possible, right? 100%. So can you give example why with alloying conductivity goes high or conductivity goes down?
স্যার যদি আমরা
Pure
ক্রোমিয়াম ইউজ
interconductor
করি তাহলে তো কন্ডাক্টিভিটি হাই হয়ে যায় না?
Again,
স্যার
sorry.
আগের দিন যেটা কার্বন আর সিলিকন
Adding germanium to silicon.
Right. So in
কার্বন আর
case of
সিলিকনের যে স্যার
semiconductor,
এক্সাম্পলটা দিয়েছিলেন
right, in case of semiconductor, if we increase the alloying elements, no, that was a different thing actually. Okay, carbon and silicon example, that is a different thing. But in case of p-type n-type material, you know that with the doping there is a huge concentration of electron and hole and conductivity increases, right? Obviously we'll discuss that in detail when we'll discuss semiconductor. But in case of semiconductor, with doping, conductivity goes high. Everyone knows it, right? So with doping, conductivity can goes up. In the another question is the conductivity of steel or iron, which one is higher? Conductivity of stainless steel or pure iron, which one will be higher?
The pure iron is high.
Pure iron.
Pure iron.
Right. That means in metal, if you add alloying elements, that will scatter the electron and conductivity will goes down. So when you will look for copper wire for your wiring, will you look for high conducting wire or low conducting wire? High purity wire copper or low purity copper?
High purity.
high purity,
হাই
High
পিউরিটি
purity.
high conductivity.
usually more than 99.99 or 99.995%, okay? On third digit, it is essential 99.99 or 99.995, because if you have little bit even impurity, it will scatter the electron. So we also need to understand why in some material adding impurity decrease conductivity. Again, in semiconductor, only adding impurity increase the conductivity. So material behave differentially. Again, you see that crystal structure, then phase structure, the texture, these things also is going to affect your conductivity. So we need to understand why material behave differentially. Why material behave differentially in response to temperature, or in response to hot rolling, cold rolling, or in response to any heat treatment, or in response to any fabrication method. So that means in any way, if there is any structural modification, then material's property changes. So in today's lecture, we understand that conductivity or including any property is very much material structure sensitive, right? For different material, things will work differentially, and that's why we need to understand the electronic structure of material, and we have to see that what is the structural difference, that's why material behave differentially. Okay, আজকে এই পর্যন্ত, আমরা নেক্সট ক্লাসে আবার দেখবো বাকিটা আর কি। আচ্ছা, তোমাদের সিআর এর সাথে মনে হয় একটু কথা বলেছিলাম, তোমরা কি ওয়েডনেস স্যাটারডে সানডে মানডে টুইসডেতে কি তোমরা একটা ক্লাস নিয়ে আসতে পারো? আমাদের সুযোগ আছে
স্যার
তোমাদের?
হচ্ছে টুইসডে স্যার হচ্ছে পুরোটাই ব্লক আর কি, মানে পুরো সবগুলো স্লটই আর কি ফাঁকা নাই, মানে আমাদের দুই গ্রুপেরই প্রায় একটা পর্যন্ত ক্লাস আছে আর কি, 8টা থেকে আর কি।
আচ্ছা মানে তোমাদের একটা না ক্লাস হচ্ছে না? আচ্ছা
হ্যাঁ
ঠিক আছে,
স্যার।
অসুবিধা নেই, আপাতত চলো কিভাবে, অসুবিধার কিছু নাই। ঠিক আছে, তাহলে থ্যাংক ইউ সবাইকে। হ্যাঁ, আমি
স্যার
আমি ভিডিও লেকচারটা পরে তোমাদের সাথে শেয়ার করে দিব সিআর এর সাথে।
ওকে স্যার, থ্যাংক ইউ।
হ্যাঁ, ওকে, ঠিক আছে।
থ্যাংক ইউ আসসালামু আলাইকুম।
আসসালামু আলাইকুম স্যার।
আসসালামু আলাইকুম স্যার।
থ্যাংক ইউ স্যার।
আসসালামু আলাইকুম।